Hi everybody. So this is the first part of a video presentation in which my partner Alejandro Sabre and I will talk about the engine design process. First of all, we have to take a look at this figure from the book Elements of Propulsion from Mattingly, which shows the typical design procedure for aircraft gas turbine engines, which in general terms include turboprop, turbojet, turboshaft, and turbofan engines. This schematic diagram shows us the relationship between thermodynamic, aerodynamic, mechanical, and control system design. As you can see, feedback is one of the most important parts in this procedure due to the simple fact that manufacturing feasibility must be considered at all times. So between the different systems that we've already mentioned, we have several feedback channels. First of all, the design process is shown as starting from a specification, resulting from either market research or a customer requirement. Actually, the specification normally results from market research because there are very few customers who are powerful enough to have an engine built to their specific requirements. The development of a high-performance gas turbine is extremely costly, so this means that it may be shared by several companies. Most people may think that the specification is a simple statement of required power and efficiency, but nothing further from reality. Other factors of major importance, which vary between the applications, will include weight, cost, volume, and life expectancy. After the specifications are already put together, we can go to the preliminary studies, which basically are the choice of cycle type of turbomachinery layout. It is essential to consider at an early stage what type of turbomachinery and combustor to use, and this will, in large measure, depend on the size of the engine, and in particular by the airflow required. Thermodynamic design. These are detailed calculations taking into account all important factors such as expected components efficiencies, air bleeds, variable fluid properties, and pressure losses, and will be carried out over a range of pressure ratio and turbine inlet temperature. In industry, these calculations will be carried out using sophisticated software, but we must understand that there is no value mathematically defined optimum. For example, at a specified turbine inlet temperature, a large increase in pressure ratio may give a minimal improvement in specific fuel consumption, and the resulting engine would be too complex and expensive to be practical. Other considerations, such as mechanical and aerodynamic design, must be taken into account in this stage. The thermodynamic design point calculations, having determined the airflow, pressure ratio, and turbine inlet temperature, can be turned into the aerodynamic design of the turbomachinery. So it is now possible to determine annulus dimension, rotational speeds, and number of stages. At this point, we can find the first feedback in which the aerodynamicist can ask the thermodynamic designers to change something in favor of the final product, perhaps a slight increase in turbine inlet temperature, or a decrease in pressure ratio, or an increase in rotational speed. Mechanics. The mechanical design can start only after the thermodynamic and aerodynamic design themes have established the key dimensions of the engine. This is because probably they may find that stress or vibration problems may lead to further changes. Detailed design and manufacture. At the same time as the mechanical studies are proceeding, off-design performance and control system design must be considered. Off-design operation will include the effects of both varying ambient and flight conditions and reduced power operation. When designing a control system to ensure the safe and automatic operation of the engine, it is necessary to be able to predict parameters such as temperatures and pressure levels throughout the engine and to select some of these as control parameters. After all this, we move to the final stages of the process, which are the test and developing stage, in which the prototypes are tested and the results rated to see if the engine works as expected. After that, we move to the production stage. From here, we can see an operated and modified versions feedback. This is because the design of the engine must be carried out with consideration for future growth. Once the engine has entered service, there will be demands for customers for more powerful or more efficient versions, leading to the development of operated engines. This, of course, will lead us back into the thermodynamic stage, and from there the process repeats itself. Once the production is finished, the engine is finally complete and ready to go, which means that it is allowed to field service and that our process is done.